ファミリーコンピューターに夢の大冒険ゲームスーパーマリオブラザーズ。秘密の力で大きく変身。地上に地下に。
One of the best parts with making these videos is the research I do for the intro. Seeing commercials of products I used to adore as a kid from other cultures than mine is just heartwarming. Well, anyway, I've been wanting to make a Super Mario tutorial in JavaScript for a while. It's quite a big project and will take a couple of weeks to complete, so this tutorial will be episodic. Let's get started with episode 1. In this first episode, we're going to focus on creating backgrounds with tiles. So we have this tile set here, and I'm going to draw a background with it. The first thing I'm going to do is set up the project. I have created a folder here called Super Mario, and I also entered that folder here in my terminal. So the first thing I'm going to do is initialize this with npm. So we write npm init, and we're going to just answer that everything here is okay. I clear the terminal, and if I open this now in Sublime, you can see it created a package.json. And now I'm going to create the first index.html. So we'll create a new file. I'm going to save this in a folder called public. Write public here, enter the folder, and write index.html. This is what I named the file. We're going to make a very simple, just bootstrap HTML file here. So just write HTML. Oh, thanks Sublime. We named it Super Mario. And here we're just going to say hello world. And that's great. So this whole project is going to run on a web server. So let's get that started now. I go back here to my terminal, and I'm going to use a web server called serve that you can get from npm. So I'm going to write npm install serve and then save. If we go back to Sublime now, we can see here that it has added serve as a dependency. We're gonna use serve here to serve this this project. We're gonna add a custom start script here. We name it start, and then the command that's gonna run is serve, and we're gonna point it to the public directory. Save this, and let's try this out. Clear, npm run start. Okay, looks good. It started a web server here for us on localhost 5000. Let's enter it, and we see hello world. That's great. So just so you know, I have zoomed in here a little bit. So if you think that it looks too small for you, that means that that is because I zoomed in the whole website. Now I'm gonna replace hello world here with a canvas. Canvas ID is going to be screen, and the width is going to be 640. Height is going to be 640, and we close it. I'm also going to add our main script here. So we write script type equals module. This attribute type set to module means that we're using ES6 module syntax. You can only use this in Chrome version 61 or above, and some other browsers. If you want to be sure this works for you, make sure you run in Chrome 61 or later. So the source of a main script is going to be in a subfolder called JS, and it's going to be named main.js. If you run the web server now here, you can see we couldn't find it, which is all good because we haven't created it yet. Let's go back and do that here. New file. And create a new folder called, that's not right. New folder called JS. And I create a file here called main.js. The first thing you're going to do is access the canvas and paint on it, just make sure that works. So I write const canvas equals document.getElement by ID, and the ID was screen. And the reason I can write screen here is of course because I have screen here. Then to access the context, which is contains the API that we actually draw with, say context equals canvas.getContext 2D. And as a proof of concept, I'm just going to draw a black rectangle. So context.fillRect 0, 0, 50, 50. So now we know that we can access the canvas and the context and draw on it. So now I want to load this tile file here. So I'm going to Google for Super Mario tile set. And we can find this file here. Let's go in here and let's see if we can draw this to the folder here. Yes, we could. I'm going to draw it into public, and I'm going to draw it, and I'm going to create a new folder here that's called image, which I put it in. And that looks all good, right? Nice. I'm also going to rename it to tiles.png. So back to the code now. And up here, I'm going to create a little function that can load this image. We call this function load image. It takes a URL and it returns a promise. Return new promise. Solve here. And in the promise, we create an image instance. New image. On the image, we attach an event listener. Add event listener that we listen for the load event. And the load event fires when the image has been downloaded and is ready for display. And on the load event, we will resolve this promise with the image itself. Resolve image. In order to activate the image downloading, we need to write image.src equals URL. Now we should be able to say load image here. And we want to load the tile set that is in image tiles.png. And then we chain a then function and the image comes out. Now we want to draw the image directly on the context or the canvas. So we can say context.draw image. We provide the image and we say where. So that's 0, 0. Let's close this down here. And what happens? Okay, so we draw the entire image here now. We only want to draw a subset of the image. So in this case, I want to draw this first tile here that is the ground. And if we go back to our code, we can see that the draw image method, it can take a lot of arguments. If I add arguments like 16, 16 here, let's see what happens. Now it draws a tiny version of the whole tile set up here. That's not what we want. So it turns out this draw image method is what you call polymorphic. It does different things depending on the number of arguments and the type of the arguments. And in order to do the right thing, we want to add some more arguments here. We can here add what offset we want to use. So if I add 0, 0 and 16, 16, again, if we say, if we generate the right result. So this basically means, here's the subset we want to draw, here's where we want to draw it. So if we want to change where we draw this image, we can update these parameters. Now we moved it. And if we want to change the size, we can change these two parameters. So they're basically groups of 2 or groups of 4, depending how you see the resizing images. But obviously, this is a very inconvenient way of drawing a subset or drawing a sprite here. So I'm going to mock an API here for how I want this to work. I would like to be able to say const sprites equals new sprite sheet, and I want this to take the image. Then I want to be able to define sprites with names. So I say sprites, and I better change it to sprites here too. Dot define. I'm gonna give it a name, and this gonna be ground. And the ground I want to be at 0, 0. I also want to define that the tile set tile size is 16, 16 here. Then once a sprite is defined, I want to be able to draw this sprite on the context. So sprites.draw ground on context at, for example, 45, 62. 62. So now we're gonna implement this class. I'm gonna write it up here. Class sprite sheet. The constructor takes an image, a width, and a height. And let's save these three arguments as properties. This.image equals image. This.width equals width. This.height equals height. Then we want to implement the define method. And the define method looks like this. It takes a name, it takes a x and a y coordinate. So in the define method, I want to save this subset of the image to a buffer. So it basically, instead of having to draw from the big image every time, we can create a buffer where we keep the tile. So I say const buffer equals document.create element, and we create a canvas element. So this will create the exact same element as we have done here, except that here it was created by the browser when it read HTML, and here we create it programmatically with JavaScript. Then we want to set the width and the height of this canvas. So it's gonna say buffer.width equals this.width, buffer.height equals this.height, and then we want to draw the subset of the image in this buffer. So buffer.getContext 2D, and we need to chain to this, so I'm gonna do this and draw dot draw image. We're gonna draw this dot image, and we want to draw it as x times this dot width. We want to know this is the subset, and we want to use y times this dot height, and the size of the subset is this dot width and this dot height. And then finally we want to draw the full buffer of this subset. So 0, 0, and this dot width and this dot height. So once we are drawn on this buffer, I want to save this buffer in a map. So let's add a tile map up here. This dot tiles equals new map. And in the end of this method, we can add the buffer to this map using the name. This.tiles.set, name as key, and buffer as value. Then the last thing we want to do here is we want to draw it. So we had a draw method, draw, name, context, x and y. And this looks like, I'm just gonna scroll down a little bit. First we retrieve the buffer from the tile set. Const buffer equals this.tiles.get name. And then we draw the buffer at x and y. So context.draw image buffer at x and y. And let's try it out. And there it is. So now we're drawing with the sprite API here. And that's much nicer because we can say draw ground context here and here. And we can repeat this easily without having these numbers. So now let's remove the legacy draw call. Let's try this again. And everything looks good. Now I want to clean this up a little bit. So I'm gonna move the sprite sheet class here to a module. Then removing it from here, cutting it out. Then I create a new file, I'm pasting it in here. And I clean this up a little bit. And then I save this as spritesheet.js. Then I want to import it here instead. So in the top of this file, I write import spritesheet from spritesheet.js. And in order to be able to write import, I have to export it from here. So I write export default class spritesheet. And the default keyword allows me to import just the first thing from this file. I don't have to specify what. Let's see if this works now. And it does. So we have some cleanup and no problems. So while we're cleaning up, I might as well decouple this load image function. So I cut it out, create a new file, paste it in, and I'm gonna save this as loaders.js. Now I want to import this in the main file, so I write import, and this is gonna be a named export, so I say load image from .loaders.js. And just like with sprite sheet, we need to export it. So we go and write export function here. And it still works. So now I want to define another sprite. I'm closing loaders for now, and I'm closing this index2 and the package.json. And then I want to define a new sprite. I want to define the sky sprite. So we name a new define here, and we say sky. Then we want to find this. Where is it? So this, I better zoom this in a little bit. So now I want to find this sprite here, and it looks like it's about 23 and 3 or something. So we say 3x and 23 here, and then we change this to sky to see if we draw the sky now. And we do. That's fantastic. So if we draw sky over the entire canvas now, we will create a Super Mario sky. So how can we do that? Well, one obvious thing we can do is to use a for loop. So let's write one now. For let x equals 0. So that's the first spot I want to draw with the sky. And I want to draw for at least, let's say 25. So while x is less than 25, then plus x there. Yips. And then in a loop for let y equals 0. And it should be at least 13 from top to bottom. So while y is less than 14, then plus y. Then just repeat this draw call with the sky sprites. And instead of setting the exact numbers here, we're gonna set x and y, but we need to multiply them by 16 because the draw method doesn't take tile sizes. So where did this lead us? Here. So now we draw a big piece of the canvas with this sky tile texture here. Now I want to add a little convenience method here. I don't want to have to say times 16 here all the time. So I'm going to go back to the sprite sheet class, scroll down to draw, and I'm going to add another method here. And this method is going to be called draw tile. It takes the name and the context, just as this other function, and x and y. But this calls draw name context with x times this dot width and y times this dot height. Now let's see if we can use this instead in main. So draw and remove the multiplier here. Great. Now let's see if we can draw some ground. I'm going to duplicate this for loop. And the ground should cover the whole left to right, but not the entire vertical. We only want to draw the ground down here. So I'm just gonna set this to 12 and write ground here. So that's pretty much Super Mario for us. However, it's not that convenient to draw it with for loops, of course. So we want to simplify that a little bit. I'm going to invent a Super Mario level format here that I'm gonna specify in JSON. And using this JSON, we're gonna draw things on the canvas. So I'm gonna create a new file, and I'm gonna save this here in public. Create a new folder called levels. Enter this folder, and I name this file 1-1.json. This level JSON will contain all the information to create a level. So in the future, this will contain all the enemies and stuff like that. But now it's just going to contain the background. So I create a new key here that's called backgrounds. And background is going to be an array. And this array will contain objects. And one of the object properties here is going to be tile. And this tile name is going to be sky. Then we're going to set the range for this tile. So we set ranges. And this is going to be an array of arrays with data in them. So instead of having to specify this for loop, I also want to specify the start of x, the end of x, and the start of y and the end of y. So we can basically tell this format just draw things, so just cover the screen with tiles at specific places. So here we have 0 to 25 for the sky on x, and we have 0 to 14 for the sky on y. So let's go back here to a format, and we should just be able to say 0, 25, and 0, what was it, 14. I'm gonna save this, and now we're gonna create a little loader for this JSON. So back to main, and actually, yeah, let's put this in loaders. So I'm gonna open loaders here, loaders, and I'm gonna create a new function here called load level. Export function load level, and it's just gonna take a level name, and using this name we can create URL. Return fetch, we fetch from levels name.json, and we treat it like JSON here. Now let's import it here, load level, and we will be able to load this level after we have loaded the sprites. So let's run load level here, load level, and it's 1-1. Then level should come out, and let's console.log this to make sure it looks okay. Great, here's the level now. It has backgrounds, it has a background and the tile is sky, and the ranges are defined here. There's one range, and we're going to be able to do multiple ranges. For the sky, we will only ever have one big range, but for example, for the ground, it will not be ground everywhere. It will have holes and gaps and stuff like that, and some other things that are even more specific. So we're back in the code now, and we can remove this old legacy fill rectangle, and I'm going to create a little new function here called draw background. Function draw background. And what this is going to do is take a background from a JSON. It's going to draw it on a context using a sprite set. On the background, we want to loop over all ranges. So we say background.ranges.forEach. And now we can interpret that array that we defined here. So this can be converted easily to x1, x2, y1, and y2. We can do that by writing x1, x2, y1, y2. Then we copy the for loop from down here up to the function, and we can just replace the constant numbers here with our values from the JSON. And the background.tile will replace the sky text here. That didn't work, and that's good, because we want some bugs, right? So let's see what happened here. We have sprites, we have the context. Did we send in them correctly? No, we haven't even launched it function. So let's go down here and say draw background, level.backgrounds. And the first only. We send in, what is it? The context, and then the sprite set. That's all blue, very nice. And now we want to do this to all backgrounds. So I'm gonna remove this ground for loop and go back to here. I'm gonna define a new background. It's ground, and the range is a little bit different. It's still the whole left to right, but from top to down I think it's 12 to 14. And if we go back to main and loop over all backgrounds and draw them, this should now draw the ground too. So level.backgrounds.forEach and background, move that, and we just use that background from the for loop. And let's see what's going on here. No, we missed something. Oh yeah. An express. There we go. So now we're drawing backgrounds in Super Mario from a Super Mario tag set with the level format defined in JSON.